Hi, hello, Dr. Wang here. Today I'm going to do a training video for this assignment. In this assignment, we're going to use the SAPIO platform to simulate a restriction digestion on plasmid PMSH2 and PRS413. We have annotated these two sequences under assignment plasmid editor 2. So if you need their sequences, this is where those sequence files are. So the first thing I'm going to do is to go to my SAPIO account and then create a new module. So you can certainly enter the sequences by importing. However, there is a shortcut since I have already annotated those two sequences in this assignment. What I'm going to do is to go there, make sure that I register the sequences. Right? So if I register the two sequences, this makes sure that I can reuse these two sequences elsewhere. All right, so I'm going to minimize this module. Now create a new module. So instead of uploading files, I'm going to choose an existing sequence. So first, I'm going to choose this one. Since I registered the sequence, now it's available to me. All right, so simply click, and then this is going to display this sequence. I'm also going to rename this module as basically 3 restriction enzyme digestion. All right, so the next thing I'm going to do is to open a new tab and then to add my PRS413 sequence. Okay, so now both sequences are added. So what I'm going to do now is to go over how to use the restriction enzyme digestion function on SAPIO. So let's look at the questions here. The first question asks, how many times does enzyme NOT1, the last letter here is a Roman numeral, so it's pronounced NOT1, cut PMSH2? All right, so how many times does it cut? I'm going to first make sure I'm looking at PMSH2 and then go to this restriction digestion button, click on that. So currently it's set to display enzyme with maximum of 2 cuts, right? So I really don't know how many times it cuts. So perhaps we can increase this just to make sure that it's display like all the enzymes that actually cuts. Okay, so here, so the question asks for NOT1, right? So which is right here. So we can see that this is an enzyme that recognizes sequence GCGG, and then cuts in between C and G right here. So we can see that this enzyme cuts PMSH2 1 time. All right, so this is the answer for the first question. The second question asks for how many times does enzyme BAGO2, right? So again, the last 2 letters are Roman numeral for number 2. So this is BAGO2, cut PMSH2. So we're going to look for this enzyme again. We can certainly click on enzyme to sort this list alphabetically. So then you're going to find BAGO2 fairly easily. And then here is how many times does this enzyme cut PMSH2. So this is question number 2. All right. So question number 3, right? So if we use this 2 enzyme to cut PMSH2, which of the following statement would be true? So here we're coming back to SAPIO, right? So I'm going to close this and then click on a different button, which is right here, right? So this button here, when you click on that, you will see analysis options. We are going to do a restriction analysis. This opens up a new tab. All right, so the question asked for, we're going to digest this plasmid. So I'm going to select it first. And then when I scroll down, this list will allow me to choose the enzymes, right? So we can do basically three enzyme, right? So a sort of a three enzyme digestion. In this case, we are just doing a double digestion. So digestion with two enzymes. The first enzyme is STU1. So I'm going to scroll down to look for STU1, which is right here. So I'm going to click on that. And then the second enzyme is NAE1, right? So I'm going to go to the second list, choose NAE1, it's right here. So we can see that over here, this is basically a simulated restriction digestion product run on agarose gel. We can see that there are two fragments. I'm actually going to first come back to the graphics to show you why there are two fragments, right? So let me hide the sequences. So the two enzymes is right here. So NAE1 enzyme is right here, right? So we can see this is the entire plasmid. So sequence starts from here. This is position 1, and then we're going to go clockwise to position 1750. This is the location where NAE1 cuts. So if we keep on going, go to position 2275, this is where enzyme STU1 cuts, right? So when we have a linear molecule, we cut it twice. This is going to give us two fragments, two linear fragments, right? So the first fragment is from here to here. And this is the first smaller fragment. And then the second fragment is starting from here and going all the way back to here, right? So just like if you have basically a string, you can imagine sort of like a circular string. If you cut that string twice, you're going to get two pieces of linear string, right? So sort of to give you a visual. So there are two fragments, one small from here to here, right, so from here to here, and another one from here to here, a larger fragment. And we can see those two fragments on the gel. This is the larger fragment. That's 8,800 base pair long. The small fragment is right here. That is 525 base pair long. So this is the question. This is the answer for question 3. So the next question, right? So question number 4, what if we cut PRS413 with X bar 1 and APA1? We're simply going to do the same steps. So we are going to first make sure that we are looking at the right plasmid PRS413, right? So, and then coming back to the list of enzymes, right? So first I'm going to reset the list, remove all the enzymes. And then this time we are going to choose enzyme XBA1 and APA1 from the list. Right, so and then this simulation will give you answer for question number 4. Question number 5, how many times does restriction enzyme bagel 3 cut PRS413? So here, make sure that we select the PRS413, and then you can simply go to the enzyme list and then look for bagel 2, and then the how many cuts is listed right under this column. Alternatively, you can also click on this tab, PRS413, and click on the list of enzymes, and then look for bagel 2 on this list. It should give you identical answers. So this is basically how to solve this assignment using the SAPIO plasmid editor platform to simulate restriction digestion. And you will actually be performing restriction digestion in the lab using enzyme XBA1 and APA1, right? So you're going to use this two enzyme to cut PRS413 and PMSH2. So it might be a good idea for you to simulate this digestion and then save your results so you're ready to analyze the data that you collect from this lab.